Swan derives its name from the four main elements of nature: soil, water, air, noise, which our emblem symbolizes and aims to protect. Since its inception in 1988, Swan Environmental Private Limited has been a pioneer in the supply of world-class environmental monitoring instruments and is the market leader for over 3 decades now. Swan's vision to contribute to the protection of the environment has secured its place to be a leader in the journey towards sustainable solutions. After rigorous research, we at Swan would like to introduce a parameter: total organic carbon. TOC is an effective way to measure the presence of organic substances in water, which revolutionizes the use of water resources, both for industrial and domestic purposes. The 3 major elements present in water are carbon, hydrogen, and oxygen. Thus, the presence of organic compounds in it is inevitable, as all water bodies provide nutrition to flora and fauna present within them. However, excess organic contents in the water bodies may lead to their pollution. Over the past few decades, it has been observed that there is a surge in organic contaminants across water resources worldwide. The source of these contaminants are the industrial liquid waste originating from hazardous waste dump sites, domestic sewage lines, overutilization of pesticides and fertilizers, and many such activities. These types of pollutants disrupt the aquatic life and the ecosystem as a whole. The 2 generic parameters to understand organic pollution are BOD, biochemical oxygen demand, and COD, chemical oxygen demand. BOD by dissolved oxygen method. In this method, the sample is diluted with water. The level of dissolved oxygen is measured. The solution is then left for an incubation period of 5 days, optimally at 20 degrees Celsius, after which the level of dissolved oxygen is measured again. Using a formula with the final and initial values of the dissolved oxygen, the biochemical oxygen demand of the sample obtained. BOD by monometric method. In this method, the water sample is placed in a BOD bottle. Sodium or lithium hydroxide powder is kept in a cap inside the bottle to remove any CO2 produced. The top of the bottle is fitted with a sensor and digital display, which continuously monitors the pressure. The complete system is placed in an incubator at 20 degrees Celsius for 5 days. The bacteria utilizes oxygen in the headspace, which creates a pressure drop. This pressure drop is directly proportional to BOD. COD using open reflux condensation. Titration method. In this method, potassium dichromate and sulfuric acid are added consecutively to the sample. Reagents such as mercury or silver sulfate are added to the obtained solution and is heated at 150 degrees Celsius for about 2 hours and is titrated with ferrous ammonia sulfate. It is observed that the color of the sample changes from yellowish green to purple to reddish brown. The COD value is calculated using the titration values. COD using closed reflux condensation. Colorimetric method. In this method, potassium dichromate and sulfuric acid are added to the sample consecutively in a vial with cap. The obtained solution is heated at 150 degrees centigrade for about 2 hours. The resulting chemical reaction changes the color of the sample, which is proportional to COD values. The color intensity can be measured using a colorimeter. The parameter total organic carbon, TOC, is used to measure the organic pollutants using reference standard methods. This method can be automated, which provides reliable and accurate results swiftly. Also, this method can analyze any sample without any interference. Total organic carbon, TOC, is the best alternative to conventional BOD and COD. Certain pain points in conventional BOD and COD measurements are margin of error, time consumption, usage of toxic and harmful chemicals, and incurring cost components. Whereas TOC offers a swift and reliable solution to all the above shortcomings of BOD and COD tests. Furthermore, BOD and COD can be reduced with TOC via correlation, which makes it a one-stop solution. TOC has been widely recognized as an index of water quality in terms of total amount of organic compounds. The lower the TOC, the better the quality of water, and vice versa. By monitoring TOC levels at multiple sites across a water resource, tag system can be implemented. A site and its corresponding TOC can be tagged across the water source. This in turn helps in identifying the polluting sites near the water bed. A sudden rise in TOC can trigger alerts to curb the pollution of these water resources and thus protect the water resources. Several have defined TOC limits to be 4 to 5 parts per million in the water sample taken from the source. For instance, the permissible level is 4 ppm in the US and British Columbia and 5 ppm in Korea. The TOC limits in drinking water are defined to be anywhere between 1 and 3 ppm. For instance, the permissible level is 2 ppm in the US and Ireland, 1 ppm in Korea, and 3 ppm in Japan. These TOC limits help control the carcinogenic disinfection byproducts like trihalomethane, which are generated during the process of disinfection by chlorination. TOC limits are defined for the purpose of monitoring wastewater discharge into the environment. For example, permissible limit is 1/3 of COD in EU, 1/4 of COD in Germany, 25 ppm in Austria, 20 ppm for Class 1 water area in China, 30 ppm for Class 2 water area in China, 25 to 50 ppm for STP with a capacity above 2,000 tons per day in Korea, 30 to 75 ppm for STP with a capacity below 2,000 tons per day in Korea. TOC monitoring helps us to determine water quality index and enable optimal usage of water at various stages in an industry. Generally, an industry intakes water from nearby lakes, rivers, groundwater or seawater sources for its daily operations. This source water is collected and then pre-treated using a series of treatment devices to improve its quality. The devices used for water treatment are clarifiers, ultrafilters, reverse osmosis filters, and demineralization tanks. Clarifier tanks are used to remove solids through sedimentation at the bottom of the pond. Ultrafiltration is a type of membrane filtration used to remove suspended solids and solutes of high molecular weight. The membrane filters frequently get clogged and hence are backwashed. The backwashing frequency is determined by monitoring the TOC levels at inlet and outlet to draw out high-efficiency performance and prevent any biofouling formation. Reverse osmosis filtration is also a type of membrane filtration to remove TDS, ions, organics, and larger particles. These membrane filters can also frequently get clogged and hence are backwashed. The backwashing frequency is determined by monitoring the TOC levels at inlet and outlets to draw out high-efficiency performance and prevent any biofouling formation. Demineralization is a type of water purification to remove all inorganic salts by ion exchange resins. Regeneration frequency is determined by monitoring TOC at inlet and outlets for high-efficiency performance and preventing any biofouling formation. Finally, the purified DM water is stored in tanks. Wastewaters are collected from various sources in the industry like floor drain, office building drain, coal yard watering drain, coal handling equipment drain, UF, RO, DM, polisher regeneration drain, boiler chemical cleaning drain, heavy fuel oil HFO and light diesel oil LDO tanks area drain, cooling tower drain, etc. All these effluent waters are collected in a tank and treated in effluent treatment plant for reuse in the industry. ETP has several treatment stages. Wastewater treatment. In the primary stage, wastewater first passes through bar screens to remove large solid objects and then through a grit chamber to eliminate grit like ash, clinkers, etc. Finally, it enters the primary clarifier to remove sediments. In the secondary stage, biological treatment is done in a moving bed biofilm reactor, MBBR. Here, microbes are added to the wastewater to grow on plastic carriers as biofilm, to eat away the organics and purify the wastewater. It is followed by a clarification in the secondary clarifier. Tertiary stage treatments like reverse osmosis and brine crystallization are used for further treatment to reuse the water and achieve zero liquid discharge. Overall TOC monitoring benefits in ETP. Optimization of treatment process by TOC monitoring at inlet and outlet of treatment stages. Checking MBBR efficiency by maintenance of optimal food to microorganism ratio. Maintenance of optimal carbon, nitrogen and phosphorus CNP ratio. Protection of reverse osmosis membranes and plant assets. determine treated water reusage application, thus saving the costs. These determinants empower operators to make critical decisions to protect the treatment devices, thus avoiding breakdowns in ETP, which leads to huge savings. By using the Shimadzu TOC analyzer, TOC analysis is made easy and simple. Just place the sample bottle in the apparatus and the sample is analyzed automatically. Two models are available. In the standalone model, the selection of methods and programs are inbuilt and can be accessed with the display and keyboard. TOC value of sample is displayed along with peak area. In the PC-controlled model, the software is installed on the PC and is used to select methods and programs of the TOC analyzer. TOC value of sample is displayed along with peak area on the PC. The principle to measure TOC levels in water and wastewater using 680 degrees Celsius catalytic combustion with NDIR detection is based on reference method APHA 5310B, which is a well-established and proven method for various water applications. In this method, the water sample is first diluted, then acidified and sparged. After sparging, inorganic carbon is removed from total carbon. Further, the sample is injected into a combustion oven and heated at 680 degrees Celsius with a catalyst. The sample is thus oxidized, liberating carbon dioxide, which is measured using an NDIR detector to get TOC value. Various accessories for Shimadzu TOC analyzer. First, the auto sampler. It can support 3 different vial capacities. Select the vial size required and fill them with samples. Then place them in the auto sampler. The analyzer will automatically analyze all samples sequentially. Alternatively, simpler auto samplers with 8 ports is also available, which can support any size user sample bottles. Total nitrogen module can be used to measure total nitrogen along with TOC in the same sample. The solid sample combustion unit is an additional accessory for TOC measurement in solid samples. TC and IC can be measured separately. This unit contains 2 ovens. TC oven can be chosen between the range of 900 and 980 degrees Celsius for total carbon measurement. To illustrate the process, a sample is placed into the oven using the boat sampler carefully with forceps. TC analysis of the solid sample is initiated and the TC value is subsequently measured. IC oven is used to measure inorganic carbon in solids directly at elevated temperature, 200 degrees Celsius. To illustrate the process, a sample is placed into the oven using the boat sampler carefully with forceps. The sample is then acidified with an acid dispenser and then inserted. IC analysis of the solid sample is then initiated and IC value is subsequently measured. Shimadzu has been the world leader in the manufacture of high-quality TOC analyzers since 1967. Shimadzu TOC analyzers maximize both sensitivity and productivity, making them the ideal choice for monitoring all types of water. Today, Shimadzu's TOC analyzers are the benchmarks of the industry. Swan Environmental Private Limited, a Hyderabad-based company, has been the exclusive authorized distributor in India for the Shimadzu TOC analyzer for over 3 decades. Swan is proud to announce that it has been the market leader and won several awards for being the largest seller of TOC in Southeast Asia. Thank you for watching. For more details, please contact Swan Environmental.